Hello student, now we are going to discuss about physical geography paper second, that is atmosphere. Now we have to discuss about unit third, atmospheric pressure and winds. The atmosphere is having a weight which exerts pressure. The atmospheric pressure is measured in various units like centimeter, inch, millibar, etc. The atmospheric pressure is recorded by common instruments, and these are mercurial barometer and aneroid barometer. The accounted pressure at sea level is 29.92 inches or 760 mm or 1013.25 mb. Recently, millibar is the another unit of measurement which has been used to introduce air pressure. At the sea level, atmospheric pressure is 1013.2 millibar. The distribution of air pressure is controlled by altitude, temperature, rotation of the earth, water vapor, etc. There is an inverse relationship between temperature and pressure. That is, higher the temperature, lower the pressure, and vice versa. Then, the distribution of pressure. Atmospheric pressure is not uniformly distributed. It decreases with increasing height. But height is not only common factor. Pressure changes from time to time. The variations of atmospheric pressure are either vertical or horizontal. Vertical distribution of atmospheric pressure is like as at a higher altitude, pressure of the air decreases. The rate of decrease of pressure with altitude does not same everywhere. The air is highly compressible. The lowest layers of atmosphere are the densest because of weight of the air above them. Hence, atmospheric pressure is always highest at sea level, and that is 1013.25 millibar. Generally, this decrease in pressure is at a rate of 1 centimeter per 110 meters of ascent. Beyond an elevation of 50 kilometer, the decrease of pressure extremely slight. The standard pressure with the height is like pressure at sea level is 1013.25 millibar. At a higher altitude, the air is thinner or less dense than the air at sea level. Pressure therefore decreases as altitude increases. Then we have to discuss about horizontal distribution of atmospheric pressure. The horizontal distribution of atmospheric pressure is shown on the map with the help of isobars. Isobars म्हणजे समभार रेषा. Isobar is an imaginary line drawn on a map connecting the places of equal atmospheric pressure. The Isobaric map shows that there are certain belts where the atmospheric pressure is high, while along certain zones the atmospheric pressure is low. Unequal distribution of the heat and Earth's rotation has its effect on distribution of pressure belts. In all, there are 7 pressure belts on the globe. Then the formation of pressure belts. The atmospheric pressure tends to be lower than normal in areas of great heating are known as low pressure belts, and higher in areas of little heating are known as high pressure belts. These pressure belts are not permanent. They migrate to the north and south through 5 degrees of latitudes due to the apparent मायग्रेशन ऑफ द सन. म्हणजे सूर्याच्या भासमान भ्रमणामुळे हे प्रेशर बेल्ट या ठिकाणी शिफ्ट होत असतात. फॉर द स्टडी पर्पज ऑफ द प्रेशर बेल्ट द जनरल अरेंजमेंट is taken at the time of the equinoxes when both the hemispheres receive the same amount of insolation. The pressure belts are formed like the equatorial low pressure belt. Equatorial low pressure belt is the pressure belt which lies within 5 degree north and south latitudes. It is the equatorial low pressure belt where there is a intense heating throughout the year because the angle of sun's rays is always more than 66 and 1/2 degree. High temperature causes expansion of air and consequently it becomes light and rises, giving rise to a low pressure area. This equatorial belt is also known as doldrums, though it is a region of calm. Local thunderstorms occur frequently. Then subtropical high pressure belts. These pressure belts lie between 30 degree and 35 degree latitudes in the both hemispheres, where the air is completely dry and the winds are calm and light. It is a region of descending air currents. It is frequently referred as the horse latitude. Then the temperate or subpolar low pressure belt. The temperate or subpolar low pressure belts lie between 60 degree to 65 degree latitudes in both the hemispheres. The rotation of the earth causes deflection and surface area spreads out from this zone and low pressure is caused. This subpolar low pressure belt is more developed and regular in the southern hemisphere than the northern hemisphere. In the northern hemisphere, the continuity of this belt is broken by the vast land masses of North America and Europe. The air pressure is low over the ocean where temperature differences between summer and winter are negligible. Then the polar high pressure belts at the north and south poles 90 degree north and south, where temperatures are permanently low and atmospheric pressure is high. In these areas, the air is cold, dense, and heavy, which descends down, and the atmospheric pressure is high throughout the year. Then, shifting up pressure belts and their effects. There are daily, seasonal, and annual changes in air pressure because of northward and southward movement of the overhead sun. The atmospheric pressure belts migrate to the north and south. This shifting of pressure belts is known as the migration or swing of pressure belts. The northward and southward migration of pressure belts results from the fact that the Earth is inclined at an angle of 23 and 1/2 degree on its axis and revolves around the Sun. In this inclined position, so that the Sun's rays are vertical at the equator only twice a year. These days are equinoxes. This is at the time of the vernal and autumnal equinoxes. There is a considerable north and south latitudinal shift of the wind system as the sun marches north or south of equator. Then migration of pressure belt. The position of pressure belts at the time of equinoxes म्हणजे विषुव दिवस या वेळी प्रेशर बेल्टची स्थिती कशी असते ती याप्रमाणे. ड्युरिंग द इक्विनॉक्सेस the sun is overhead at the equator and both the hemispheres receive same amount of insolation. Hence, the pressure belts lie at the same distance north and south from the equator. At the equatorial pressure belt, the position of equatorial pressure belt is like it lies between 5 degrees north and south latitudes. Then the position of subtropical high pressure belt is like these belts lie between 25 degree and 35 degree latitudes in both hemispheres. Then the position of pressure belts at the time of summer solstice, that is 21st June. With the apparent migration of the sun by 23 and 1/2 degree towards north, the pressure belts also shift by 5 degree latitudes towards north. Here we have stated that with the apparent migration of the sun, सूर्याच्या पासमान भ्रमणामुळे म्हणजे ते जवळपास 23.5 उत्तरेकडे, त्यामुळे द प्रेशर बेल्ट्स also shift by 5 degree latitudes towards north. The equatorial low pressure belt. This belt lies between 0 degree and 10 degree north latitudes. Then the subtropical high pressure belt. In northern hemisphere, this belt extends between 30 degree and 40 degree north latitudes. Then the subtropical high pressure belts in southern hemisphere. This belt lies between 20 degree and 30 degree south latitudes. Then effects of a northward shifting or migration of pressure belts. During this period, the area that lies between 30 degree south and 35 degree south latitudes become free from the high pressure belt and comes under the influence of westerlies, which give rainfall. During this period, there is a winter in southern hemisphere, and thus these winter rainy areas come into existence. Results change in characteristics of climate with hot, dry, that is a rainy climate, no doubt. The extreme South Africa, Southwest and South Australia, and North Islands of New Zealand receive rainfall from the westerlies in winter. The position of pressure belts at the time of winter solstice, that is 22nd December, with the apparent migration of the sun by 23 and 1/2 degree towards south. The pressure belts also shift by 5 degrees south, shift by 5 degrees towards south latitudes. The equatorial low pressure belt extends between 0 degree and 10 degree south latitudes, and the subtropical high pressure belt extends between 30 degree and 40 degree south latitudes in southern hemisphere. Then the subtropical high pressure belt lies between 20 degree and 30 degree north latitudes in a north hemisphere. Effects of southward migration of pressure belts. During this period, the region that lies between 30 degree north and 35 degree north latitudes becomes free from high pressure belts and comes under the influence of westerlies, which give rainfall in winter. California and the coastal areas of the Mediterranean Sea receive rainfall from the westerlies in winter. Then the next topic is winds. Factors affecting on winds. Here we have to discuss about pressure gradient, Coriolis force, and frictional force. In the first instant, we have to discuss about pressure gradient. The difference of pressure between any two places is called pressure gradient or barometric slope. Steep pressure gradient is represented by closely spaced isobars, while widely spaced isobars show gentle, म्हणजे सौम्य, gentle pressure gradient, and there is a low velocity of winds and vice versa. Then another affecting factor on wind is the Coriolis force, means here effect. Because of rotation of the earth along its axis, the winds are deflected. The force which deflects the direction of wind is called Coriolis force. Because of the Coriolis force, all the winds are deflected to the right in the northern hemisphere, while they are deflected to their left in the southern hemisphere with respect to the rotating earth. So winds blow counterclockwise around the center of low pressure in the northern hemisphere, while they blow in a clockwise direction in the southern hemisphere. Then frictional force. At or near the earth's surface, friction is an important factor affecting wind. फ्रिक्शनल फोर्स नॉट ओनली रिटार्ड्स म्हणजे कमी करणे या ठिकाणी फ्रिक्शनल फोर्स नॉट ओनली रिटार्ड्स द स्पीड ऑफ विंड बट also deflects them. The effects of frictional force is con- confined to only a few thousand meters from the surface. The hill slope or ground slope facing the winds is called windward slope, while opposite slope is called leeward slope. Winds in the lowest layers of atmosphere are influenced by the frictional force. At about a height of 1000 meter from the ground, the effect of frictional force becomes too small. Next will be continued. Thank you.